नवरात्र सुरुवात आहे त्याच्यामुळे का काय तसं काय नाही ना.
असेल पण काय माहित.
बरं ठीक आहे, काय असू दे, काय हरकत नाही, काय हरकत नाही, काय चालतं थोडंसं म्हणजे असतात ना 10-15 इतर असतात त्याची, असं आहे माझं कमीत कमी. ठीक आहे. Okay, let us join to the third unit of this LIC papers, that is the having the code BAT 502 as far this paper is concerned, that is linear integrated circuits. So it deals with the study of the small integrated chips or the huge circuit have been built in a small space, that is called the integrated. That huge circuit or the complex circuit have been integrated means it is a connected very small space, that is called the microelectronic technology, and that is known as a IC, that is called an integrated circuit IC, and that IC have been implemented for the different applications as a linear application, as a non-linear applications as far the electronic circuit is concerned, the electronics mechanism is concerned, or the electronic system design is concerned. ह्या जर विचार केला तर आपल्याला अशा प्रकारच्या छोट्या अशा प्रकारच्या इंटिग्रेटेड सर्किटचा उपयोग करून व्हेरी बिग सर्किट आर डिझाईन, व्हेरी सिस्टम्स आर डिझाईन अशा पद्धतीने केलं. सो लेट अस जॉइन टू द third unit from the same papers, that is called the filter. So in the filter unit, already uh, uh, we have seen about the filter, concept of filter, definition of filter, types of filter, that is active filter and the passive filters. What are the advantages of the active filter over the passive filters? Then the very fundamental types of the filter, that is called the basic filters, that is the low pass filter, high pass filter, band pass filter, band stop filter, and all type of the filter. So this is all about the filters, fundamental filters. And then again the special type of filters, this is a fundamental filters, that is having a five subtypes are there: low pass, high pass, band pass, and band stop, and all pass. Then again, like you students, young students or the young scientists have designed a special type of filters for the special applications, So according to this, again there are various filters, that is called the Chauvet filter, Butterworth filters. Then one more filter is there, that is the another type of one filter is there. Ripple filter is there. Means a ripple filter, Chauvet filters. Then Bessel's filters. So these are the various types of the filters which have been designed by the scientists in the world for the special applications. So according to this, that filter are named their names like that way. We are going to see that the introductory part of the two filters, that is the flat cat filters or the ripple filters पाहणार आहोत, and Chauvet filter, हे दोन filters त्याच्यामध्ये आपण पाहणार आहोत. Then afterwards we should join to the what is order of filter, how to design the first order low pass filter, second order low pass filter. Similarly, we are going to see or we have to study the design the high pass filter, that is first order high pass filter, second order high pass filter. Then we have to join to the band pass filter. That means how again the band pass filter have two types, that is the wide band pass filters and the narrow band pass filters. Again, the band pass filter is on the same actions. We are going to see the two types, that is the narrow band pass filters and the wide band pass filters. And the last article from this topic is the all pass filters. Mostly the main objective of this topic is the student have to able to design and develop the various order of filters for the various applications. Means the students are able to design the low pass filter of the second order, low pass filter of the first order, high pass filter of the first order. That means student has to acquire the designing skill. What I'm saying, that designing skill. So this is the main objective or main theme or the main skill or the main central idea behind the filter topics. And there is some mathematics. If the word designing is there, that means there should be some algorithm is there. There should be some mathematics is there. There should be some thinking is there. Some logical thinking is there. Then analytic thinking is there. And by the use of this, just we have to design this different type of म्हणजेच विद्यार्थ्याला filter, definition of filter, types of filter, applications of filter, and how to design a various order of the filter in the daily life or in a system, or you are designing the any electronic systems, and in this electronic system, one of the stage or one of the block might be a filter circuit. Whereas in this block or in this system, just we are going to send some sort of band of frequency, and we are going to block the certain band of frequency. That means some blocking the band of frequency or attenuating band of frequency or transmitting the band of frequency. At the same time, we have to implement the filter concept or the filter circuit implementations. So this is the key idea behind the unit number 3. तर लक्षात आलं का, तर ह्या टॉपिक मध्ये हे विद्यार्थ्यांना येणं अपेक्षित त्याच्यामध्ये आहे. ओके, त्याच्यानंतर जस्ट वी आर गोइंग टू सी the one by one. So these are some highlights. Just I have elaborated this one. Just I will share the screen. Already share the screen there. Okay. Then presentation is there. Is it visible?
Yes, sir.
Okay. Is it? It is visible for you. All this one. So as this one, it is the title of this one is filters. That is already. So we are going to see the what is filter. So we are very much familiar with the adapted with the filter. So already in our daily life we are heard the name that is filter, that is the water filters, then air filters, or in the most of the vehicle also where they are using the filter, that is the like the sponging type of filters is there for the air circulation inside the engines. There are filters. Then the air filter is there. Then different type of filters. So that means filter, that concept or the word itself suggests that it indicates that the meaning of that filter is nothing but literal meaning. Apart from this wave filters, the filter means it can say send out or it can transmit. Okay, the wanted band of frequency or wanted things or expected things, and it can block the unexpected things. थोडक्यामध्ये सांगायचं म्हणलं की नको असते त्या गोष्टी आपण ब्लॉक करायच्या, हव्या असलेल्या गोष्टी पाठवायच्या, त्याला आपण फिल्टर म्हणतो. आणि त्याच्यामध्ये आपल्याकडं बरेच फिल्टर्स आहेत, एअर फिल्टर्स आहे, वॉटर फिल्टर्स आहेत, प्रत्येक फिल्टर्स आहे त्याच्या. आणि तसं आपल्या इलेक्ट्रॉनिक्स मध्ये सुद्धा फिल्टर्स आहे, अँड दॅट आवर इलेक्ट्रॉनिक फिल्टर इज नोन ॲज अ वेव्ह फिल्टर. आता वेव्ह म्हणजे अनेक वेव्ह आल्या. वेव्ह म्हणजे काय नसतं, वेव्ह म्हटलं की तुमच्या समोर साइन वेव्ह येते, साइन वेव्ह, देयर इज नो सिंपल साइन वेव्ह, देयर बी अनदर टाइप ऑफ वेव्ह. That may be square wave, that may be triangle wave, that may be another wave, that may be periodic wave. What I am saying that signal may be a periodic signal, and if the periodic signal is occurring at a certain period of time t, it have a frequency, and if it have a frequency, that is known as a wave, or it is known as a regulated wave. And such types of wave have a frequency, and we are going to say a block, stop, the high frequency, low frequency, band of frequency. Certain band of frequency should be rejected, certain band of frequency will be attenuated. Attenuation करणे म्हणजे लक्षात घ्या, हा शब्द मी अटेन्युएट वापरतो सारखं. तर अटेन्युएट करणे म्हणजे काय करणे, तर थांबवणे, टू ब्लॉक, टू प्रिव्हेंट. प्रिव्हेंटचा अर्थ PREVENT, प्रिव्हेंट म्हणजे टू स्टॉप करणे, टू ब्लॉक करणे. तर त्याला आपण प्रिव्हेंट म्हणतो आपण, किंवा त्याला ब्लॉक म्हणतो, त्याला म्हणतात अटेन्युएशन, म्हणजे अटेन्युएशन कॉन्स्टंट म्हणतो. किती फॅक्टरनं तुम्ही ती वेव्ह काय करतात, ब्लॉक करू शकता, त्याला म्हणायचं अटेन्युएशन. अँड अकॉर्डिंग टू दिस इट इज अटेन्युएशन कॉन्स्टंट. म्हणजेच याचा अर्थ काय की फिल्टर इज नथिंग बट इन आवर इलेक्ट्रॉनिक्स, फिल्टर इज नथिंग बट इट इज अ बँड ऑफ फ्रिक्वेन्सी, द सर्टन बँड ऑफ फ्रिक्वेन्सी which will be transmitted, okay, at the expected level or desired level or desired destinations, and block the unwanted band of frequency. So that means, in other words, we say that filter is an electronic circuit which passes a certain band of frequency and block or the stop or attenuate or prevent a certain band of frequency. So this is second definition. So our third definition is filter is a circuit which can invoice a certain wanted band of frequency. A wanted band of frequency may be transmitted or may be passed, and unwanted band of frequency may be rejected, or unwanted band of frequency should be rejected. So this is the thing. Means by transmitting, by passing a specific band of frequency and attenuating or preventing the or blocking a specific band of frequency. That is known as a filter circuit. This is a concept of filter circuit, or this is a definition of filter circuit. And filter circuit have been implemented in the almost in all electronic circuits. What I'm saying, that all electronic circuits, that filter have the task in the some of the circuit. The filter have the task to block the AC, to block the DC, to block in the filter circuit to attenuate the certain band of frequencies. Okay, like that way, you are only they can send the sound of these frequencies. So this filter plays a very important role in the design. Mostly it will be implemented in the communication circuit. Okay, almost that means they can use the communication industry. That communication industry is a very huge industry. That means communication industry have a data intelligence. That data intelligence will be sent to the transmitter stations person. That will go to the receiver stations, and in this receiver station, that means in this between this communication system, or between this communication system, you can implement the filter circuit at the transmitting end as well as the receiving end. या ठिकाणी सुद्धा त्या फिल्टरचा उपयोग केला जातो ब्लॉक करण्यासाठी, ट्रान्समिट करण्यासाठी, किंवा फेज करेक्शन साठी. व्हॉट आय एम सेइंग दॅट द फेज करेक्शन. आता मी बोलतोय, आता बोलल्यानंतर समजा ज्या इन्स्टंटला टाइम टी इक्वल टू 0 ला मी जस्ट आय एम डिलिव्हरिंग द माय लेक्चर, ॲट द सेम टाइम द स्टुडंट हॅज टू रिसीव द माय लेक्चर ॲट टाइम टी इक्वल टू 0, but it doesn't happens due to the delay of time, or due to the resistance in the space, resistance in the atmosphere. That signal may be slightly resistance to block there for a certain period of time. म्हणून थोड्या अगदी मायक्रो सेकंदानंतर आपल्याला ऐकू येतं. काही ते मॅच वगैरे बघा, लाईव्ह मॅच असेल जिथं असेल तर त्याच्यानंतर आपल्याला एक थोडस मायक्रो सेकंदामध्ये किंवा डिलेनं तुम्हाला ऐकू येतं तिथं थोड्याशा डिले नंतर. अशा पद्धतीने त्याच्यामुळे हे, आणि हा डिले तो कमीत कमी मिनिमाइज करण्यासाठी या फिल्टरचा उपयोग केला जातो. म्हणजे दॅट इज कॉल्ड द फेज करेक्शन करण्यासाठी केला जातो. सो दिस इज द डेफिनेशन ऑफ फिल्टर सर्किट. अगेन रिव्ह्यू दिस. द फिल्टर इज अ सर्किट which passes a certain band of frequency and block the certain band of frequency. Or in other words, दूसरी definition है, filter is an electronic circuit which passes a wanted band of frequency and rejects, stops or attenuates unwanted band of frequency. So this is also known as a filter circuit. Means, and that filter circuit have been implemented in the almost all electronic circuits for filtering actions of the signals, filtering action of the frequency, and mostly it will be used in the communication systems. They have for the phase corrections and for sending the data or sending this one. Again, filter is concerned. This is just as I told you the definition of noise rejections, and this one separation of industrial measurement, feedback phase and amplitude control servo loops. These are some applications we have phase correction circuit, smoothing to D2A convert signals, and variety of other circuits. So this is a definition of this one. Just already this one's told you. And again, the filter can be either classified into two types. That is the active filter and the passive filter. तर फिल्टरचे दोन भागामध्ये आहेत, एक ऍक्टिव्ह फिल्टर और द पॅसिव्ह फिल्टर. द सर्किट which are designed by the passive element. We are able to, the students are able to design a filter circuit by the use of resistor, capacitor, or inductor. By the use of out of these three components, passive component, we can use a two component. Just we can use a LC by using the LNC, it forms the LC filter. If you use RNC, it will form a RC filters. And then again the LC सांगितलं तुम्हाला आहे, and then RL filter is not there, but C must be there. C must be there, including this LC filter and the RC filter. And just by the use of the passive elements, you are able to design a electronic circuit, and that can form a filter circuit. That filter circuit is known as a passive filter circuit. Similarly, active filter. Active filter is nothing but it can use the active device or active element in designing of the filter. That is called the active filter. So active means, what is meant by active and passive? We can try to understand what is a slight difference between the active and the passive. So passive means nothing but it is a element which have no source of energy. There is no own energy source. But active element or active devices have their own source of energy. What are the active devices? Active element, active devices कुठले आहेत? Diode is active devices, transistor is active devices, all ICs are active devices, all FETs are active devices. म्हणजे all semiconductor devices are active devices. Since why? Since the active devices, as far as we can take a diode, we can take the transistors. That means there is a PN junction or the NPN junction. Between the junction, there is a internal barrier potential is there. They form an internal barrier potential, or that is called the battery. That means the have a barrier potential of the silicon that is concerned. It have a zero point 0.7 volt, and that of the germanium have a 0.3 volt. What it indicates? That can indicate the source of energy, and that source of energy, how the energy in terms of voltage is a 0.3 volt or zero point 0.7 volt, and this is nothing but this is the old source of energy which are inside the active devices, that is inside the diode, inside the transistor, inside the ICs. But ICs मध्ये कशा असतात? So basically ICs have been designed developed by the semiconductor devices. त्याच्यामध्ये डायोड असतात, ट्रान्झिस्टर्स असतात, म्हणजे त्याचा अर्थ काय झाला, आयसी सुद्धा ऍक्टिव्ह डिव्हाइसेस त्याच्यामध्ये बनले. सो दॅट the active devices, I will try to differentiate between the active devices and the passive devices. The active devices have their own source of energy. That is nothing but all semiconductor devices, and the ICs comes under this category. Similarly, the passive devices is nothing but it does not have a source of energy. There are source of energy नसते त्याच्यामध्ये. Okay, it is passive. That is resistor, capacitor, inductor. That is called the passive element. And if you design, if you do develop, if you build or assemble the circuit by the use of passive element as the R and C, it forms the RC filter. If you use a L and C, it forms the LC filter. It is called the passive filter. Similarly, the active devices mean you can use a 741. It is nothing but one of the operational amplifier. It is nothing but integrated chip, and that integrated chip will be used along with the passive component. It form a circuit, and that circuit known as a active filter circuit. म्हणजेच IC or active devices along with the passive, that type of filter is known as a active filter. So this is the major two types of the filters, and already I have told you that is passive built with this resistors and capacitors like that way. Okay, that means then we are going to see the what is difference between the active devices, sorry, active filters and the passive. तुम्हाला लक्षात आलं का active आणि passive म्हणजे काय? What is the active filters and passive filters?
हो सर.
The active filters म्हणजे काय? The filters which are designed with the active devices, that is along with the IC
ICs.
plus the passive components. Along with the passive component, it whatever the it can whatever the form the circuit, that circuit is as a active filter circuit. म्हणजेच the filter circuit, that is passive element along with the activity is known as a active filter circuit. तर पॅसिव्ह म्हणजे पॅसिव्ह मध्ये दोन असतात, म्हणजे दोनच कुठले कंपोनंट वापरून करू शकतो. देन वी आर गोइंग टू सी व्हॉट इज द ॲडव्हान्टेज ऑफ दिस ऍक्टिव्ह फिल्टर अँड द पॅसिव्ह फिल्टर. समटाइम्स द क्वेश्चन मे बी आस्क्ड इन द एक्झामिनेशन्स, गिव्ह द डिस्टिंग्विश बिटवीन द ऍक्टिव्ह फिल्टर्स अँड द पॅसिव्ह फिल्टर्स. सो वी हॅव टू फर्स्टली वी हॅव टू डिफाइन दॅट the first the difference or distinguish point is that the active filter uses the active devices like IC and the transistors and the diodes. Similarly, passive filters uses the passive element as resistor, capacitor, inductors. Then active devices have the flexibility of the gain control. What I'm saying that active filter have the flexibility of the gain control. यामध्ये गेन कंट्रोल करू शकतो. म्हणजे तो फिल्टर आहे, त्या फिल्टर सर्किटचा गेन आपण 10 ठेवू शकतो, 20 ठेवू शकतो, 100 ठेवू शकतो. म्हणजे किती त्याचा गेन कंट्रोल फ्लेक्झिबिलिटी आहे. परंतु तसं पॅसिव्ह फिल्टरला गेन फ्लेक्झिबिलिटी फॅसिलिटी नाहीये. हा दुसरा त्याच्यामध्ये आहे. तिसरा जो आहे ती हाय ऍप्लिकेशनसाठी, दोन्ही सुद्धा हाय ऍप्लिकेशनसाठी त्याच्यामध्ये आहे, पण रिलेटिव्हली दी ऍक्टिव्ह फिल्टर्स आर व्हेरी कॉस्टली, ओके, फॉर हाय फ्रिक्वेन्सी ऑसिलेशन्स, हाय फ्रिक्वेन्सी फिल्टर सर्किटसाठी. बट ड्यू टू द मास प्रोडक्शन्स ऑफ द ICs, that active filters are cheaper than the passive filters. तर पॅसिव्ह फिल्टर्स मध्ये तुम्ही घेतला तर काय घेतला, एलसी फिल्टर घेतला. एलसी फिल्टर घेतला म्हणजे कॅपॅसिटर आला, एक इंडक्टर आला. आता इंडक्टर तुम्हाला पाहिला, तुम्ही इंडक्टर पाहिल्यानंतर तुम्हाला काय दिसतं, त्याच्यामध्ये इंडक्टर मध्ये मोठा ट्रान्सफॉर्मर दिसतोय. त्या ट्रान्सफॉर्मर मध्ये काय केलं असतं, लॅमिनेटेड कोर्स असतात. त्या लॅमिनेटेड कोर मध्ये काय केलं असतं, वायरिंग गुंडाळलेले असतात शेपमध्ये, ई शेप मध्ये किंवा व्ही शेप मध्ये किंवा एल शेप मध्ये. आणि त्या वायरिंग केल्यानंतर त्याच्यापासून दोन वायर काढल्या असतात. आणि असा मोठ्या पद्धतीचं एक आपण काय करतो, आपण त्याला आपण म्हणतो इंडक्टर म्हणतो. इंडक्टर इज नथिंग बट इट इज अ कॉइल विच आर वाउंडेड ऑन द कोर मटेरियल किंवा एल टाइप्स ऑफ स्ट्रिप्स वर गुंडाळलेले असतात आणि फॉर्मचे दिस टाइप ऑफ पॅसिव्ह डिव्हाइसेस. आणि तसा तो इंडक्टर कसा आहे, साईजनं मोठा आहे, म्हणजेच इट इज अ व्हेरी बल्की, मोठा असतो. त्याचा ट्रान्सफॉर्मर इज नथिंग बट इट इज वन ऑफ द इंडक्टर. म्हणजे त्याच्या जर तुम्ही प्रायमरी वापरल्या तर इट वर्क्स एज इंडक्टर, हे सेकंडरी वापरल्या तर इट वर्क्स एज इंडक्टर. मी काय म्हणतो लक्षात ट्राय टू अंडरस्टँड. इंडक्टरचा कन्सेप्ट काय की इट इज नथिंग बट इट इज अ कॉपर कॉइल विच आर वाउंडेड ऑन ए स्ट्रिप्स. दॅट स्ट्रिप मे बी आयरन स्ट्रिप्स असतील, फेराइट स्ट्रिप्स असतील, ह्या एल शेप्ड मध्ये असतील. तर त्याच्या पद्धतीला आपण काय म्हणतो, इंडक्टर म्हणतो. म्हणजेच थोडक्यामध्ये जर इंडक्टरचं बघितलं, वी कॅन लुक ॲट द इंडक्टर, we can look at its physical side. Its physical size is very large, power consumption is large, so that the circuit which is designed, that circuit is a big circuit, and that's why it is not easily transportable. ट्रान्सपोर्टेशनचा जर विचार केला तर थोडंसं ते बल्की वाहून नेण्यासाठी, परंतु 741 ऑपरेशनल अँप्लिफायर इंटिग्रेटेड चिप बघितली तर इट इज व्हेरी स्मॉल, अतिशय स्मॉल आहे. अगदी मिलीमीटरची लांबी रुंदी त्याच्यामध्ये असते आणि त्याच्यावरती दोन सर्किट जो लिंकिंग होते स्मॉल. त्यावेळी इंडक्टर वापरायचा नाही तर त्या वापरायचा आपण RIC, रेजिस्टर छोटा असतो, कॅपॅसिटर छोटा असतो, म्हणजे दॅट सर्किट बिकम्स व्हेरी स्मॉल. अगदी 1/1 सेंटीमीटर मध्ये सुद्धा, तर त्याच्या कमी स्पेस मध्ये सुद्धा, किंवा सिम्युलेशन मध्ये तर काय अगदी मायक्रॉन मीटर मध्ये ते सर्किट बसवलं जातं. हा त्याचा एक ॲडव्हान्टेज त्याचा आहे. म्हणजे दिस इज ॲडव्हान्टेजेस ऑफ द ऍक्टिव्ह फिल्टर. दॅट मीन्स दॅट सर्किट कॅन बी सिम्युलेटेड इन अ व्हेरी स्मॉल स्पेस. इट डज नॉट रिक्वायर द इंडक्टर. आणि इंडक्टर आला की काय होतं, त्याच्यामध्ये पॉवर एनर्जी येते, पॉवर एनर्जी त्याच्यामध्ये येते, याच्यामध्ये येते, इंडक्टरमध्ये येते, म्हणजे रेडिएशन सुद्धा येऊ शकतात त्याच्यामध्ये, आणि बल्की आहे. सो दिस इज द disadvantages. So that as far as the cost is concerned, for the low frequency, due to the mass production, the active filters are very cheaper than the passive devices. But the passive filters have very high quality factors. Quality factors जास्त आहे याच्यापेक्षा. पण त्याचं लिमिटेशन एकच आहे. काय त्याचं लिमिटेशन कुठलं, की हाय फ्रिक्वेन्सीला ऍक्टिव्ह फिल्टर्स ऍट हाय फ्रिक्वेन्सी दे आर कॉस्टली. त्याचं मॉडिफिकेशन जरा हे होतं, जसं कॉस्टली येतं, हाय थोडासा डिसएडव्हान्टेजेस आहे. परंतु या पॅसिव्ह फिल्टरचे बरेच डिसएडव्हान्टेजेस आहे त्याच्यामध्ये, बरोबर आहे. त्यामुळे हे म्हटलं की युजफुल फॉर द हाय फ्रिक्वेन्सी. सो दिस इज the range of the quality factor possible active filter up to close of few hundred. म्हणजे मी आता म्हटल्याप्रमाणे the quality factor of the active filter is very high as compared to the LC filters or the passive filters. हे तुम्हाला सांगितलं की लार्ज इंडक्टरची गरज नाही आणि तो कॉस्ट आहे सांगितलं. जे आता मी सांगितलं तेच आहे. पॉवर कन्झम्पन्स आहेत, त्याच्यानंतर गेन फ्लेक्सिबिलिटी आहे, जस्ट जे आता मी म्हटलेलं आहे ऍक्टिव्ह फिल्टर्स आर इकॉनॉमिकल दॅन द passive filter, cheaper म्हटलेला. So these are the some different types of filters. तुमच्या लक्षात आलं का, हे जे मी आता सांगितलेलं आहे ते तेच आहेत. म्हणजे स्टॅबिलिटी चांगली आहे, पॉवर इज रिक्वायर्ड टू ऑपरेट द ऍक्टिव्ह लिमिटला. एक हाय फ्रिक्वेन्सी ऍक्टिव्ह फिल्टर्स आर मोर एक्सपेन्सिव्ह. आता मी तुम्हाला सांगितलंच आहे त्याच्यामध्ये की जर तुम्ही ऍक्टिव्ह फिल्टर तुम्ही बांधले आणि त्याचे हाय फ्रिक्वेन्सी बांधले आणि गेन फ्लेक्सिबिलिटी, किंवा त्याला आपण काय म्हणतो आपण त्याला की व्हॉट आय एम सेइंग दॅट देयर इज अ गेन फ्लेक्सिबिलिटी इज देअर फॉर ऍक्टिव्ह फिल्टर्स, बट देयर इज नो सच टाइप्स ऑफ फ्लेक्सिबिलिटी. त्या गोष्टी थोड्याशा दिस लिमिटेशन्स अँड सम distinguish point between the active filters and the passive filters. Then we can turn to the next type of filters. तुमच्या लक्षात आलं. आता तुम्ही मला फिल्टर्स किती सांगता सर म्हणणार, सर किती फिल्टर सांगितले, शुभ म्हणणार किती फिल्टर सांगितले. तर अकॉर्डिंग टू द डिझायनिंग, बरं का, अगोदर मी काय सांगितलं, डेफिनेशन ऑफ फिल्टर, ऍप्लिकेशन्स ऑफ फिल्टर, टाइप्स ऑफ फिल्टर, ऍक्टिव्ह फिल्टर अँड पॅसिव्ह फिल्टर्स अकॉर्डिंग टू डिझाईन सांगितलेलं आहे. जर तुम्ही ऍक्टिव्ह एलिमेंट आणि पॅसिव्ह एलिमेंटचा केला तर तो ऍक्टिव्ह फिल्टर होतो, आणि पॅसिव्ह एलिमेंटचा वापर केला तर तो पॅसिव्ह फिल्टर होतो. आणि पॅसिव्ह फिल्टर करण्यासाठी आपण रजिस्टर कॅपॅसिटर इंडक्टरचा वापर केला. तो ऍक्टिव्ह करण्यासाठी ऍक्टिव्ह एलिमेंट मध्ये कुठलेही सेमीकंडक्टर डिव्हाइसेस किंवा आयसी अलॉंग विथ द पॅसिव्ह एलिमेंट केलं तर आपण म्हणतो त्याला ऍक्टिव्ह फिल्टर्स म्हणतो. आणि त्याच्यातला फरक जे तुम्हाला सांगितला की त्याची साईज, त्याची पॉवर, त्याची लोड कंट्रोल, ते हायब्रिड ऑपरेटिंग, त्याच्यानंतर ट्रान्सपोर्टेशन त्याचं कसं आहे, क्यू फॅक्टर कसा आहे, या गोष्टी तुम्हाला त्याच्या दोनच्या डिस्टिंग्विश झाल्या. सो दीज आर द नथिंग बट मेजर द क्लासिफिकेशन्स ऑफ द फिल्टर अकॉर्डिंग टू द हार्डवेअर डिझाईन म्हणूया आपण त्याला. काय म्हणूया आपण? हार्डवेअर डिझाईन कन्सेप्ट. रिगार्डिंग द हार्डवेअर डिझाईन कन्सेप्ट आपण त्याच्यामध्ये म्हणू आपण. आणि नंतर ह्याचं जे क्लासिफिकेशन मी सांगितलेलं आहे, types of filters. Though this is the various types of filter. Again, these types of filters is nothing but that filters have been classified according to the operations, okay, according to the range of frequency, according to the frequency. म्हणजे लो पास म्हटलेला आहे फिल्टर, हाय पास फिल्टर, बँड पास फिल्टर, बँड रिजेक्ट फिल्टर, and ऑल पास फिल्टर. These are some fundamental filters according to the frequency range. म्हणजे लो पास फिल्टर म्हणजे काय? The name itself suggests that it can pass the low frequency components and reject or attenuate the high frequency component, किंवा high frequency signals किंवा high frequency data, high frequency इंटेलिजंट, कुठलाही इंटेलिजन्स आपण म्हणूया आपण, किंवा डेटा म्हणूया. त्यानंतर हाय पास फिल्टर मध्ये काय जातो? हाय पास फिल्टर इज अ सर्किट इन व्हिच हाय फ्रिक्वेन्सी फिल्टर्स, in which high frequency band of high frequency will be transmitted, will be sent, it will be passed without attenuations, and low frequency will be blocked or rejected. As the high. Then the band pass filter, the name itself suggests that a certain band of frequency will be passed without any attenuations from source to destinations and rejects or block the band of low frequency or band of the high frequency, or the band below this pass band and the band above a pass band. आपण सांगणार आहे तुम्हाला पास बँड म्हणजे काय, स्टॉप बँड मध्ये मी तुम्हाला सांगणार आहे. त्यानंतर द बँड रिजेक्ट फिल्टर. बँड रिजेक्ट फिल्टर म्हणजे काय? इट इज अ filter in which a certain band of filter will be blocked, stopped, or rejected. That is called the band reject filters, and the remaining band of frequency will be passed. That is called as a band reject filter. And the last type is nothing but all pass filter. All pass filter is filter, it can pass all frequencies, all data, all intelligence from source to destinations, but it have a one, that is a limitations or disadvantages, is that whatever the intelligence we have transmitted pass from source and it is received to the destination, they the same signal is received at the receiving end. That means when we are transmitting the data or any signal from the source, that same signal have been received at the destination without with constant amplitude, but there is a change in phase. फेज मध्ये काय होतो? बदल होतो. म्हणजेच इन ऑल पास फिल्टर इट कॅन पास ऑल फ्रिक्वेन्सीज with constant amplitude, but there is a phase difference between the a transmitting signal and the receiving signal. तर त्यासाठी फेज डिफरन्स फक्त त्याच्यामध्ये येतो, किंवा फेज डिफरन्स किंवा फेज डिले विल बी ऑकर्स बिटवीन द इनपुट आउटपुट. म्हणजे इनपुटला साइन वेव्ह दिली 1 व्होल्टची पिक टू पिक, सेम तिथे तुम्हाला पिक टू पिक 1 व्होल्ट मिळणार आहे, पण त्याच्यामध्ये काय येणार आहे तुम्हाला? फेज लॅग मिळणार आहे, फेज डिफरन्स मिळणार आहे. म्हणजे ट्रान्समिटिंग एंडला आणि रिसिव्हिंग एंडला जर तुम्ही सिग्नल बघितला तर दोन्ही सिग्नल सारख्याच असतील अँप्लिट्यूडला, पण फेज डिफरन्स त्याच्यामध्ये मिळणार आहे. परंतु सर्वच्या सर्व सिग्नल म्हणजे लो फ्रिक्वेन्सी असतील किंवा हे असतील, म्हणजे थोडक्यामध्ये ऑल डेटा, ऑल सिग्नल्स हॅव्हिंग द रेंज फ्रॉम 1 हर्ट्ज टू द infinity hertz, that data will be transmitted without attenuation with constant amplitude, but there is a phase correction between the transmitting and the receiving end. Only there is a difference between this all pass filter. So this has some, again, the fundamental classification of filter according to the range of frequency. low pass filter, high pass filters, and band pass filter, band stop filter, and band reject filter. So can look at this one. मला एक दुसरं एक सांगतो त्याच्यामध्ये, की त्याच्यामध्ये कसं असतं. आता याच्यामध्ये पाहतो मी, याच्यामध्ये काय दिसतं तुम्हाला? यू कॅन लुक ॲट दिस वन. These are some responses. तर इथं 1 minute. Hmm. I remember. Didn't I remember? 8 minutes. ओके ठीक आहे. लेटस मोठ येते दिस वन. ठीक आहे, त्यात थोडासा काहीतरी प्रॉब्लेम ह्याच्यामध्ये मला दिसतोय. दिसतोय. सेव्ह केलं का? ठीक आहे. Okay. Okay, look at this one. The left side diagram, that is the nothing but gain against frequency. त्याच्यामध्ये गेन अगेन फ्रिक्वेन्सी तुम्हाला दिसतो. त्याच्यामध्ये काय दिसतं तुम्हाला? Okay, we just have plotted the graph of this one, that is nothing but frequency against the gain. The frequency taken on the x axis. त्याच्यामध्ये जर पाहिलं तर फ्रिक्वेन्सी आपण कशामध्ये घेतलेली आहे? x axis वर घेतलेली आहे. Okay, the frequency taken on the x-axis, that is f, and the gain of the filter is given by a, which are taken on the y-axis. म्हणजे याचा अर्थ, just this is the first graph. It shows that the frequency response for the low pass filters, this one is concerned. इथे दिसतंय तुम्हाला. एक मिनिट. ओके, ठीक आहे. द फ्रिक्वेन्सी अगेन्स्ट द गेन, ते काय दिसते? द as frequency increases from 0, the gain a0 remains constant. At particular frequency the gain will be drops. बरोबर आहे? असं जस्ट गेन विल बी गो ऑन डिक्रीजिंग त्याच्यामध्ये होऊ लागलेलं आहे. आणि ॲट वन फ्रिक्वेन्सी दॅट गेन विल बी ड्रॉप्स. ओके, that frequency is known as a cutoff frequency, and that is known as a higher cutoff frequency, that is f0. That means the band from the 0 to f0, that band is known as a pass band. That type of frequency will be passed from source to destination without attenuations, and the frequency from f0 to f is equal to infinity, that band of frequency is known as a stop band. म्हणतात आपण. काय म्हणतो त्याला आपण? स्टॉप बँड असं आपण म्हणूया. म्हणजेच any filter circuit is concerned, that may be low pass filter or that might be high pass filter, so which have two bands, that is a pass band and a stop band. Pass band is nothing but band of frequency. What is pass band? Pass band is nothing but band of frequencies that should be passed from source to destination, one point to another point, without any attenuation, without any blocking action, is known as a pass band. And stop band means the band of frequency the range of band of frequency in which that band of frequency has been rejected, or that band of frequency doesn't allow to go from one point to the another point, or from source to destination. It is called the stop band. That means, just I would like to conclude that the that means any filter circuit is concerned, that might be low pass filter, that may be high pass filter, band pass filter, band stop filter, band reject filter. We can take any type of filters. That means that filter, every filter have two bands. That is known as one is known as a pass band, and second is known as a stop band. And we can try to understand the meaning of the pass band. This pass band is nothing but the range of band of frequency. That range band frequency will be transmitted. That will be sent. Okay, to one point to the another point without any attenuations, or it will be transmitted without any blocking state. And stop band means the range of band of frequency. That band of frequency will be attenuated, or it will be rejected. That does not allow from source to destinations from one point to the another point. So this is known as a stop band. And again, one more thing is that the pass band have the maximum gain. What I'm saying, that the pass band have the a very good quality of the gain, or it is a maximum gain, and that gain is a constant gain. What may be, if it might be one, it might be two, it might be three, whatever may be the gain of that filter circuit, that will be remains the constant. It have a good quality of the gain. But as far as the stop band is concerned, and for the ideal stop band is concerned, for ideal filter is concerned, it have a zero gain. म्हणजे it does not have any gain, it does not have any power. म्हणजे त्याची गेन किती असतो, झिरो असतो. म्हणजे गेन इन द पास बँड इज मॅक्सिमम, or it is high, and the gain in the stop band, it is a zero. What I'm saying, that band is zero. The pass band have the maximum gain, and stop band have the zero gain. So this is all about the a pass band and the stop band, or the difference between the pass band and stop band. And every filter have the a pass band and the stop band. As far the low pass filter is concerned, it have one pass band and the one stop band. The bands high pass is concerned, one have one stop band and the pass band. And band reject and band stop concerned, it have a one stop band and a two pass band, and two stop band and the one pass band. And all filter have only one pass band. So these are nothing but related to the pass band, related to the stop band, and difference between the pass band and how it will be occurs in the different type of this one. Just this is nothing but practical curve, and dotted curve shows that means as frequency increases, gain remains constant, and at certain frequency gain immediately drop, which is shown by the dotted line. This is nothing but this is the response for the ideal filter circuits, and the gain will be constant. Afterwards, gain increases linearly, decreases, and that is nothing but this is the practical response for the filter circuits. Then this is how two types of response is there. That is ideal response is there, and practical response is there. So this is all about the different type of filters: low pass, high pass, band pass filters. And not tomorrow, but day after tomorrow, again just we go to the high pass filters, then band pass filter, band reject filter. त्याच्यानंतर त्याचे फिल्टर्स म्हटले त्याची रेंज काय असते, आणि दुसरे बेसल आपलं जे आहे चौबासे फिल्टर आणि रिपल फिल्टर्स, हे दोन फिल्टर बघायचे. अँड देन आफ्टर वी हॅव टू जॉईन टू द डिझाईन ऑफ द फर्स्ट ऑर्डर लो पास फिल्टर्स. त्याच्यानंतर आपण डिझायनिंगला जाऊया ऑर्डर ऑफ फिल्टर. तर त्याच्यानंतर आपण एक त्याच्यामध्ये पाहू शकतो आपण. ओके, चालेल. तर शुभम, जस्ट आय विल कम टू द फ्रंट साइड, याला येतो, मग आपण हे पाहूया त्याच्यामध्ये.